18 and this is our tricycle. The main idea behind this tricycle is for us to make something strong, lightweight, but also appealing to the children. I will explain further on these details during the presentation. Now let's go through the main parts of this tricycle. First, let's talk about our handlebar. It's made out of aluminum and painted red. The reason why we went with aluminum is we need something relatively cheap but also lightweight so that it's easy for the children to control. Now let's talk about the most important part of the bike, the main frame. As you can see, it's made of aluminum painted red. We added these patterns for extra friction on the back, and also you have the shaft on both sides and the stoppers for the wheels. The main frame is the part that carries all the load of the bike when riding. That's why we need something strong, which explains the thickness of the frame, but it has to be lightweight because it has to be easy to carry the bike around. Now let's talk about a wheel. It's very simple, rounded metallic aluminum wheel with rounded side. We also added these holes so that we can add the shaft, connecting the core and the rim with the pattern tool easily. The shaft itself is made out of also metallic aluminum, and there are 12 of them on each side. For safety reasons, we added 2 sides of shafts on each wheel. Since this is a product for children, safety has to be one of the most important elements. Now moving on to the tire. The tire is made out of rubber for friction reason, and we added 3 lines of patterns on each tire for added friction between the tire and the road. And this is the pedal bar. It is basically an aluminum shaft that connects the wheel and the pedal. When we put force on the pedal, it will spin, making the front wheel spin, therefore driving the whole bike. And this is the pedal itself. It's made out of plastic because of economics reason. It also has holes in the middle to save material. Overall, it's a very simple, common pedal. And this is the seat. It's made out of rubber and rounded on every corner to make the ride as comfortable as possible. It's also positioned in the middle of the bike so that weight is distributed equally. As you can see, this is a bike when it's moving forward. All the wheels are moving at a constant velocity and the pedals are parallel to the ground. This is the bike when it's turning. As you can see, the handle is tilted at an angle, but all the wheels are at the same velocity. As you can see, the front wheel is acting as a guidance wheel. Most of the parts in our bike has to be able to move freely. That's why we picked clearance fit for most of them, except for the seat, which has a transition fit. Now I will talk about the front wheel tolerances. For the bike fork, we can see that the hole on it has a tolerance of plus or minus 0.02 mm. Now for the shaft on the pedal bar, we can see that it has a tolerance of 0.01 mm, making the front wheel system a clearance fit. Moving on to the tolerances on the pedal. As you can see, the tolerance on the shaft is about 0.01 mm and the tolerance on the pedal itself is 0.02. So the whole system is a clearance fit. Now for the back wheel's tolerances, we already know the hole on the wheel has a tolerance of plus or minus 0.02 mm. Now the shaft on the frame has a tolerance of about 0.01 mm, making the whole system a clearance fit. On to the handle shaft tolerances, we know that the hole on the frame has a tolerance of plus or minus 0.02 mm. And for the shaft on the handlebar, we know that it has a tolerance of plus or minus 0.01 mm, making the whole thing a clearance fit as well. Now the seat doesn't rotate around, so we picked a transition fit. We can see that the seat has a tolerance of 0.02 millimeters and the bar has a tolerance of 0.02 millimeter as well. Well, that's all from group 18. I hope you guys enjoyed the video and thank you for watching.